Today we are solving LeetCode 304 range sum query 2D immutable. This is a very important prefix sum problem. In this problem we will learn key DSA concepts. First, how 1D prefix sum extends to 2D matrices. Second, how to answer repeated range sum queries efficiently. Third, why brute force is too slow when many queries are asked. Fourth, how extra padding in a prefix sum helps avoid boundary mistakes. And fifth, how to be very precise with index, column index, +1 and -1. Let us first understand the problem. We are given a 2D matrix. We have to implement a class called num matrix. This class has two parts. First, the constructor num matrix. This class has two parts. This is the constructor and this is the function. So the constructor initializes the object with the given matrix. Second, the function some region with parameters row1, call1, row2 and call2. This function returns the sum of all elements inside the rectangle whose top left corner is row1, column1 and bottom right corner is row2, column2. The important condition is this: some region must work in O1 time. That means every query should be answered instantly. Let us take the example matrix. Suppose the query is some region 2, 1, 4, 3. This means start row equals 2, start column equals 1, end row equals 4 and end column equals 3. So we need a sum of this rectangle. This sum we need to find out. And the sum is 8. So the answer is 8. Now let us think of the brute force approach. For every query, we can run two loops. One loop from row 1 to row 2, and another loop from call 1 to call 2. Then we add all elements inside that rectangle. The brute force code would look like this. Total equals 0 for range R in range row 1, row 2 plus 1. For C in range call 1, call 2 plus 1. Total plus equal matrix R C. This works correctly, but the problem is time complexity. In the worst case, one query can cover the entire matrix. The matrix size can be 200 by 200. So one query can take M star n, and there can be up to 10,000 queries. At most, 10,000 calls will be made to some region. So brute force can become too slow. We need some region to run in of order 1 time complexity. So time complexity is of the order M star n. That means we need some region to run in order of 1. That means we should do some pre-processing in the constructor. This is where 2D prefix sum comes in. Before understanding 2D prefix sum, let us remember 1D prefix sum. for an array 3, 0, 1, 4, 2. The prefix sum stores cumulative sum from the beginning. So it becomes 3, 3, 4, 8, 10. Now if we want sum from index 1 to index 3, we can do prefix 3 minus prefix 0. That gives us 8 minus 3 equals 5. Which is 0 plus 1 plus 4. In 2D prefix sum, we do the same idea, but for rectangles. We create another matrix called prefix. Prefix R, C will store the sum of all elements from the top left corner up to that point. But to avoid boundary mistakes, we create prefix with one extra row and one extra column. So if original matrix has m rows and n columns, then prefix will have m plus 1 rows and n plus 1 columns. This extra row and columns will contain zeros. For example, say a new matrix called prefix, ignore the self part, equals 0 star n plus 1 or underscore in range m plus 1. So this will have m plus 1 and n plus 1 rows and columns. Now this is very important. Original matrix uses zero-based indexing, but prefix sum uses shifted indexing because of the extra row and column. So matrix I, j will contribute to prefix I plus 1, j plus 1. This plus 1 is very important. Now how do we fill prefix? For each cell matrix ij, we want the sum of the rectangle from matrix 0, 0 to matrix I, j. The formula is let us understand this formula. This is prefix I plus 1, j plus 1 equals matrix I, j plus prefix I, j plus 1 plus prefix I plus 1, j minus prefix I, j. So matrix I, j is the current element. Prefix I, j plus 1 gives the sum above the current cell. Prefix I plus 1, j gives the sum on the left side. But when we add above and left, the top left area gets counted twice. So we subtract prefix ij once, I, j once. That is why the formula has minus prefix I, j. This is the core idea. Now let us understand how to answer a query. Suppose we want to run the sum of a rectangle, row 1, column 1 to row 2, column 2. So prefix has we want to find this sum. Since prefix has one extra row and one extra column, we convert the bottom right position by adding 1. So R1 equals row 1, C1 equals col 1, R2 equals row 2 plus 1, C2 equals col 2 plus 1. Now the answer is simply this. Let us understand this. Prefix R2, C2 gives the sum from the top left corner to bottom right of our required rectangle. But this includes extra area above the rectangle. So we subtract prefix R1, C2. It also includes extra area to the left of the rectangle. So we subtract prefix R2, C1. But now the top left area has been subtracted twice. So we add prefix R1, C1 back once. This is exactly the same inclusion-exclusion idea. Now let us write the pseudocode. So this we will write in constructor. M equals number of rows and n equals number of columns. Create prefix matrix of size m plus 1 cross n plus 1 for I from 0 to m minus 1 and for j from 0 to n minus 1. We compute prefix I plus 1 comma j plus 1 by this formula. Now we start writing the sum region function. The pseudocode for this. So R1 equals row 1, C1 equals col 1 and R2 equals row 2 plus 1 and C2 equals col 2 plus 1. And we simply return by computing the prefix sum. Okay, so now let us write the Python code. So let us comment out everything. Let's now initialize the self.prefix, the prefix sum matrix with m plus 1 rows and m plus 1 columns. Then we write the loop for I in range n and for j in range n. We compute the prefix sum by the formula. Then we start writing the sum function. Finally, we return the answer. Now let us dry run one query. Let us dry run. Suppose the query is sum region 2, 1, 4, 3. So row 1 equals 2, col 1 equals 1, row 2 equals 4 and col 2 equals 3. Because prefix has one extra row and column, so this R1, R2 will change. Now the answer is simply this. This gives the sum of the exact rectangle from row 2 to row 4 and col 1 to col 3. And result is 8. Now let us test the other example. Sum region equals 1, 1, 2, 2. So result is 8. The rectangle is this. And the sum becomes 11. So output is 11. Okay, now let us analyze the time complexity. In the constructor, we go through every cell once. So preprocessing time is of order m star n. For every sum region query, we only do 4 prefix lookups and a few additions and subtraction. So query time is of order 1. The space complexity is order m star n. Because we store the prefix matrix. Now let us submit this solution. Actually, we could decrease the space complexity because in this formula, the pre-computation part, you see that prefix I plus 1, j plus 1 depends only on matrix I and j. So, and rest are all prefixes I plus 1. So, if that is prefix I comma j, then can I compute mm, matrix ij from there? From there, if I'm given prefix ij, prefix ij plus 1, prefix I plus 1 comma j. Okay, okay, fine. So we can very easily compute in a space complexity of order 1, just like we calculated the prefix sum in the last video, where we were updating the matrix ij itself. So it is possible to do it in order 1 space complexity. Let us submit the problem anyways. Okay, so all the test cases pass. Let us finally discuss some critical mistakes. One important point is this passes because the matrix is immutable. Immutable means the matrix will not change after initialization. So we can safely preprocess the prefix sum once and reuse it for all queries. Now let us discuss the common mistakes, forgetting the extra row and extra column. If you do not use padding, boundary cases become difficult. Confusing matrix index and prefix index. Remember matrix ij goes to prefix I plus 1 comma j plus 1. Then forgetting to subtract the overlapping top left area while building prefix. The build formula is current plus above plus left minus overlap. Then mistake number 4 is using row 2 and call 2 directly in the sum region. Since prefix is shifted, we must use row 2 plus 1, call 2 plus 1. Mistake number 5 is forgetting to add back the top left overlap in the query formula. The query formula is big rectangle minus area above minus area left plus overlap. So the final formula is prefix R2, C2 minus prefix R1, C1 minus prefix R2, C1 plus prefix R1, C1. So let us recap. In this problem, brute force checks every cell inside the rectangle, but that is too slow for many queries. The optimal solution is to pre-process a 2D prefix sum matrix. Once prefix sum is ready, every sum region can be query can be answered in order one time. The most important thing in this problem is index precision. Original matrix uses normal zero-based indexing. Prefix matrix has one extra row and one extra column. So always be careful with +1 while building prefix and while answering queries. That is the complete solution for LeetCode 304 range sum query 2D immutable.